Today we're starting triangle congruence proofs. We're going to focus on side, 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 and side, angle, side triangle congruent theorems today. First off, if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts. The first way is using side, 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 also referred to as SSS. Whenever you're doing a side, side, side triangle congruent, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. For this example, if segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF, then triangle ABC is congruent to triangle DEF. Looking at example 1, we're given that segment PQ is congruent to segment ST, segment QR is congruent to segment RT, and R is the midpoint of segment PS. What we're trying to prove is that triangle PQR is congruent to triangle STR. First thing you need to do whenever we do any of these proofs is to mark your picture so we can see out which way we're actually going to go to get our solution. So we start off with what we're given. Segment PQ is congruent to segment ST. We're going to mark both those segments with one tick mark indicating that they are congruent to each other. Then we're going to move to the second one, which is segment QR is congruent to segment RT. Mark those with two tick marks indicating that those two are congruent to each other. The third thing that we were given is that R is the midpoint of segment PS, which means R is directly in the middle of the points P and S, making that segment PR is congruent to segment RS. Now looking at our picture, it clearly shows that we have three different sides that are congruent to three different sides on the other triangle. So these two triangles would be congruent by side, side, side. We're going to label our picture with SSS so that we know which exact reason we're going to go for the conclusion. And I would just go ahead and circle that to make sure that we know exactly what we're going to be doing here. Now, actually looking at the bottom is where we're going to do the actual proof. On the left side is the statements, which is the steps that you are doing to get your conclusion. And on the right side is the reasons for that step. So the first statement says segment PQ is congruent to segment ST. The reason why we know that is because we were gave it, so we're going to use the reason given. Statement number 2 says segment QR is congruent to segment RT. Again, we were given that, so that is our reason. Statement 3 says R is the midpoint of segment PS. Again, we were given it, so again, given is our reason. Now, for step 4, we had to use a little bit more reasoning skills for it. When we said that R was the midpoint of PS, we concluded that PR was the same as RS. So we use the fact that R is the midpoint to say that segment PR is congruent to segment RS by definition of midpoint. Now when we look at this, we have statement 1, 2, and 4 giving you each a side of the triangles. Right? We have all three sides that we have for the theorem SSS proven and written down in our proof. So now we can conclude, based off of that, that the two triangles are congruent by side, side, side. Moving on to example 3. We're given that segment AC is congruent to segment AD, and also segment CB is congruent to segment BD. We're trying to prove that triangle ABC is congruent to triangle ABD. So again, we look at the picture first. We're going to mark segment AC and segment AD as congruent. We will then mark segment CB and BD as congruent. Then we also look at the picture and we can notice that those two triangles have a common side. That common side would be segment AB. So that segment AB has to be the same for both triangles. Looking at the picture, we can see that we clearly have three sides that match on both triangles, so the triangles are congruent by side, side, side. Again, we're going to circle that just to make sure that we realize what we're going to have for the goal. Now the difference between this and the last proof is now we are not just given the statements in a specific order that we have to follow. We have a blank slate so we can work it in any way we want. How I always end up working this is I always start off with the first thing that I'm given and work to try to get that first letter of the type of proof we're doing. So the first thing I'm given is that segment AC is congruent to segment AD. I need to show that two sides are congruent from this. That happens to be one of the two sides that are congruent. And again, the reason why I know AC is congruent to AD is it was given to us. That satisfies my first S out of SSS. So I can move to my next given statement. Segment CB is congruent to segment BD. Again, that was given to us, and that would satisfy my second S of the side, side, side theorem. Alright, now the third step, and what we marked in the picture, was that AB is congruent to AB. Now, whenever something is congruent to itself, there's a specific rule for it that we had discussed earlier, and that is called the reflexive property. Now that's either if something is equal to itself or something is congruent to itself, we use the reflexive property. That satisfies my third S for side, side, side. So, triangle ABC is congruent to triangle ABD by side, side, side. Now, side, side, side is not the only way that we can prove triangles congruent. Another way is side, angle, side, or sometimes referred to as SAS. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Another way to phrase this is if you have two sides congruent on one triangle with the angle between those two sides congruent to each other, then the triangles are congruent. For example, this one we have if segment AB is congruent to segment DE and angle B is congruent to angle E, and segment BC is congruent to segment EF, then triangle ABC is congruent to triangle DEF. Again, whenever we're doing this, we have to have the side next to an angle next to a side. Now looking at example 4, we're given that segment JM is congruent to segment NL, and angle JMN is congruent to angle LNM. We're trying to prove the triangle JMN is congruent to triangle LMN. So the first step is to mark our picture. We're going to show that JM is congruent to NL. Next step is about the angles, so we're going to mark those angles with arc marks on it. Angle JMN is congruent to angle LNM. And now the third thing that we need to notice is that these two triangles share a common side, and that common side would be MN. So that must be congruent on both of those triangles. Now if we look at this, we have a side next to an angle next to a side on both triangles. So these triangles are congruent by side, angle, side. And I'm going to circle that just to make sure that I know which step I'm going to end up going to. So my first statement says segment JM is congruent to segment NL. Again, that was given to us, so that is our reason. The second statement says angle JMN is congruent to angle LNM. Again, that was given to us. The third reason, or the statement, is segment MN is congruent to segment MN. Now, whenever we did that, it was because it was the same line, so we use reflexive property. Statement 1 satisfies the side, Statement 2 satisfies an angle, and Statement 3 satisfies the side. So we have all three parts of our SAS to say now the triangles are congruent by side, angle, side. Moving on to example 6, we have V is the midpoint of segment WZ and segment XY. We're trying to prove that triangle WXV is congruent to triangle ZYV. So, V being the midpoint of segment WZ will tell me that WV is the same as VZ. Also, V being the midpoint of XY tells me that XV would be the same as VY. Now, there's one other thing that we can get from the picture, and we have two lines intersecting, so the angles across from them have to be congruent because they are vertical angles. Now looking at our picture, we can clearly see that we have two sides congruent with the angle between them congruent, so it is side, angle, side. Again, I'll circle that so I make sure I note what I am going to do to get this final proof. Statement 1 says V is the midpoint of segment WZ and segment XY. The reason why I know that is it was given. We then concluded from there that segment WV is congruent to segment VZ because of definition of midpoint. Then we have that angle WVX is congruent to angle YVZ by vertical angles. And then we conclude that segment XV is congruent to segment VY, again by definition of midpoint. We have statement 2 giving us the side, statement 3 giving us the angle, and statement 4 giving us the other side. So we have all three parts for side, angle, side. The triangle WXV is congruent to triangle ZYV by side, angle, side.